ESA draft his 2040 strategy. The French rocket company MaiaSpace gives more insight on its development. SpaceX continues its launch site expansion. CASC is getting more sustainable. The Euclid telescope from ESA is delivering big data. What happened to Isar Aerospace and his rocket? Launches of the week. Hi everyone, I'm Christophe Paget for All About Space, and this is your space update. ESA has released its 2040 strategy, broken down into 5 goals, which are: number 1, protect our planet and climate by sending satellites to understand the planet's changes and threats to further mitigate them for a resilient and sustainable world. 2, explore the furthest reaches of the cosmos and brings us closer to answering some of the universe's most fundamental questions. 3, strengthen European autonomy and resilience by developing advanced communications to European observation and navigation solutions. 4, boost European growth and competitiveness by fostering and activating a vibrant educational, technological, and industrial European space ecosystem across the member states. And 5, inspire Europe to work as one, to combine and bring out the best in each other to offer a glimpse of the shared European future we aspire to build and elevate. Although these are merely just words, the strategy pack shows what is behind these words, something more tangible, such as speed up space debris removal, reinforcing the lunar base operation and exploitation, developing critical infrastructure to explore Mars. It also emphasizes on launch missions to gain further understanding of our universe, ensure that all European needs in satellite launches are met by European launchers, improve satellite technology to benefit European users daily, for example, improving farming productivity, early natural disaster warning and management, explore AI and quantum technology for space applications. ESA intends to nurture public-private partnerships to grow the space sector, attract more private investments, and create more jobs, and therefore enable Europe to be the leading commercial space hub by 2040. The French company MaiaSpace is developing a small rocket called Maia, capable of launching 1.5-ton payloads to low Earth Sun synchronous orbit in expendable mode, or 500 kilograms if the first stage is reused. By using the third stage, called Colibri, Maia can even increase its payload mass to orbit by 1 additional ton, and for equatorial up to 50-degree orbit inclination, would even improve the payload mass up to 4 tons. Now, the rocket will take off as early as next year from the old Soyuz launch pad and use the control center in the European spaceport in Kourou, French Guiana, and that will be without much changes to be made on it. MaiaSpace is not a company which is advertising much on what they are doing. Surprisingly, Johan Leroy, MaiaSpace CEO, was interviewed by NASA Spaceflight team recently, which provided us some insight on what is happening inside MaiaSpace, and let me summarize what we didn't know before. MaiaSpace was born from Ariane Works Studies, that is the research and technology branch of Ariane Group, less than 3 years ago to advance Ariane Group products and future developments. Johan touched on the importance of reusability, which offers basically 2 variants on the same rocket with development cost of just 1 rocket. The design choices were more on speeding up the manufacturing cycle times or cadence, rather than having a super optimized rocket, which would have been the lightest, the cheapest, and so on. They target up to 20 launches per year, with a first stage reused 4 to 5 times. The reason for using the Prometheus engine was simply to reduce the development cost and fly a rocket within 4 years, but also because the engine is designed to be reusable with its variable thrust and uses methane, which will not clog the pipes with soot as traditionally seen with kerosene, for example. And they have not started from scratch, they have already used demonstrator results such as Themis to design, build, and even test the first version of its first and second stages, along with engines, all that within just 1 year after the company was founded. They will test the ability of landing the first stage for a period of 2 years until finally tests landing on a barge in 2028 only. For competitiveness, they use stainless steel alloy for the body of the rocket. They will use the 3 engines to carry out re-entry burn to decelerate the rocket first stage and 1 engine burn for landing on the floating platform. They are not convinced by the need to recover the fairings after launch for reuse. Johan mentioned that MaiaSpace's selling point is that they are a startup company allowing doing things differently with less constraints since they are funded privately, unlike, for example, Ariane 6, and that they are a spin off company benefiting from knowledge of a well established Ariane Group workforce to avoid beginners' mistakes. Johan believes it defines the strength of MaiaSpace. MaiaSpace has just signed a multi-launch agreement with ExoTrail to launch its Spacevan orbital transfer vehicle to low Earth orbit as early as 2027 and has customers in advanced negotiations from all over the world. Thank you, MaiaSpace, for sharing some insights of your company with us. At Starbase in Texas, SpaceX is relentlessly pursuing their goals to efficiently manufacture the spaceship rocket at the highest rate possible. Now, we have already seen the birth of the Star Factory to that effect, tearing down in the process the medium and low bays. Now, this week, SpaceX is continuing that trend by starting the teardown of the high bay next to the 2 megabays in order to replace it with a gigabay, a bay about 11 times bigger than the megabay. Now, where are they going to get that space for it? It's incredible. In fact, SpaceX will also start building a gigabay in Cape Canaveral as well, as they anticipate starting Starship flights there in the early 2026. Now, Booster 16 has gone to Massey for cryogenic testing and has now returned to the production site to receive his 33 Raptor engines. The launch site is booming with construction work around the Tower Number 2, primarily around the flame trench, with about 350 cement trucks have pulled their loads to build the trench foundation. The Tower 2 arm mechanism was also being checked, and 2 power bunkers have been added to the tank farm to support the launch site with power management. The site is now getting a new concrete wall after all changes made to protect the outside during rocket takeoff. The 11th Institute of the 6th Academy of China Aerospace Science and Technology Corporation, wow, a rather complex naming, has completed its 400th engine tests of the YF-75H hydrogen oxygen engine, a new version of the YF-75D with improved turbopump speed, amongst other things. The YF-75 family hydrogen oxygen engine is used on the Long March 3A, 7A, 8, and even 8A series, typically on their third stages. It increases the engine thrust from 167 kN on its predecessor YF-75D, increased to 200 kN. I just wanted to acknowledge the effort that China is doing to use clean fuel engines. ESA has recently published the latest Euclid satellite survey results showing the cosmic web in Euclid's deep fields images, with millions of galaxies which will be revisited 30 to 52 times over the 6-year mission of Euclid to identify the cosmic evolution in an attempt to better understand dark matter and dark energy, making up 95% of our cosmos. Because of the huge accuracy of the Euclid telescope, some of the galaxies are up to 10.5 billion light years away from us, therefore reaching young galaxies. Around 10,000 volunteers are working at training an AI tool to support ESA scientists to catalog about 400,000 galaxies. This might sound a lot, but actually Euclid has only just achieved 0.4% of its total cosmic survey, so this AI tool will help in automating the catalog collection. Isar Aerospace has recently received its launch license from the Norwegian Civil Aviation Authorities, which also dictates the launch window of its Spectrum rocket maiden flight. Now, that window started on March 20th. It was then delayed day after day due to wind speeds violating the launch criteria. At the time of this recording, the launch attempt was set for March 28th after the release of this video. So good luck to Isar Aerospace. March 21st, SpaceX launched a Falcon 9 from California for its mission Enroll 57 for the National Reconnaissance Office with 11 Starship spy satellites, a derivative of the Starlink satellites. The first stage flew for the fourth time, only after 9 days since it last flew, and landed back to site. On the same day, Galactic Energy launched a Ceres-1 rocket from China for its mission Vernal Ascent, with 6 meteorology satellites based on global navigation satellite systems and infrared imager operated by Isar Aerospace. March 24th, SpaceX launched from Florida a Falcon 9 for its mission Enroll 69 for the National Reconnaissance Office with another bunch of spy satellites. The booster flew for the second time and landed back to site. March 26th, Rocket Lab launched his Electron from New Zealand for his mission with this crazy name of Finding Hot Wildfire Near You, deploying 8 German satellites with thermal infrared cameras for global wildfire detection and monitoring around the world. CASC followed with a Long March 3BE launch from China with the geostationary data relay communication satellite Tianlian 204. The last launch was from SpaceX with a Falcon 9 from California for a Starlink mission Group 11-7. The first stage flew for the 24th time and landed on a drone ship. In summary, from January 1st until March 27th, 2025, 63 rockets were launched successfully. Out of that, 41 were from an American company or institution and 15 from China. I leave you this week with very recent pictures from the James Webb Space Telescope of the NGC 2024 and SH2 277, also known as the Flame Nebula, in the constellation Orion, some 1400 light years away from us. The Flame Nebula is a hotbed of star formation less than 1 million years old. These pictures show, in fact, the differences of the Flame Nebula between the Hubble Space Telescope on the left and the James Webb Space Telescope on the right. Now, James Webb is capable of detecting what is called brown dwarfs. Now, these brown dwarfs, often called failed stars, over time become very dim and much cooler than stars, which makes them impossible to be detected by our modern telescopes. So the James Webb Space Telescope managed to pierce this dense, dusty region and has allowed the researchers to detect these brown dwarfs and get more information, which was impossible with earlier telescopes. So why would we be interested in these brown dwarfs? It's because they have similarities between both stars and planets, and therefore would help researchers to understand the big questions about star formation. Thank you for watching your channel All About Space. See you at the next episode of Space News.